Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Before you proceed, I'd like to kindly request members to subscribe to our channel so that we can be able to make a large community of members who are discussing similar topics in sciences, mathematics, physics and chemistry. And of course, I always congratulate you for the input that you are always putting in order to ensure that our content, of course, is becoming better and better each and every day. So today we're going to look at the concept of corresponding angles, and this of course is going to be a follow-up topic from the last discussion we had on the aspect of course, what we refer to as the corresponding angles. And this aspect of corresponding angles was a discussion from the aspect of what we refer to as a transversal. Now we had said that if we have two lines I and M, which are of course in the same plane, and these lines may be intersecting or not, and if there's a line that runs through them or cuts across these two specific lines, then this line is going to be referred to as a transversal, which we give as such. So we said that of course this specific line can cut across these two specific aspects of parallel lines, or lines which are running in the same plane given as such. So in case I have just a contrasted example using these two specific lines, I'm going to have this transversal and this is going to be I and M. In this second case, let's say this is a case for A and B. I'm going to have this case B whereby I is going to be parallel to M given as such. And of course, if we try to just look at these two specific examples, I'd say that we're going to have what we refer to as corresponding angles, which are going to be on the specific side of these lines of I and M given as such. So suppose we have A and B, we can be able to show that A and B are two corresponding angles given as such. So these basically angles are not the same, so I'm just going to use that specific symbol. So these angles A and B are going to be corresponding angles, and for parallel lines we can be able to illustrate that the angle A and B are going to be equal given as such. So angle A and B, so that is not the correct notation for angles, but we are considering that A and B are the central points, or just an angular extension as we can give for alpha or beta given as such. So therefore angle A and B are going to be equal, and in this specific case angle A is not going to be equal to angle B. But with regard to these two specific illustrations for these parallel and not parallel lines, we can be able to refer to these angles as corresponding. But in contrast with the B, we are going to see that in the first case, angle A is not going to be the same as B, but for parallel lines, angle A is going to be the same as B. So for the second case, we can be able to describe this particular case for the two angles, whereby angle A is congruent with angle B, given as such, as we have already illustrated in our first case for the aspect of congruence. So from this particular case, then therefore I can be able to say that if I have two parallel lines that are cut by transversals in the second case, then the corresponding angles from that specific illustration are going to be congruent as I've given it from this specific statement. Now therefore it's going to follow that another aspect of the corresponding angles from this specific illustration for my case for B is going to be involving congruent angles. If I say that perhaps this is an angle C and D, these are going to be, of course, corresponding angles, and therefore they are going to form a pair of angles which are going to be congruent. So suppose we have a general example. Let's try to look at a general example and try to consider whether those angles, corresponding angles, are going to form what we refer to as a congruent aspect or not. So I'm going to give this general case whereby we're going to have these two parallel lines for I and M, and then we're going to have a transversal given as such. So this is going to form an angle Z and X, perhaps Y given as such for line I and M. And if we try to look at this one, for given an example, given a condition, of course, that these two specific lines for I and M are going to be parallel. So we're going to consider angle Z and Y to be corresponding angles. Therefore, we can be able to give an algebraic interpretation of this, that Z is equivalent to Y given as such. And if we try to look at the corresponding angle postulate, then therefore it's going to give us an aspect of angle Z and Y being equal, as I've already illustrated from my previous example. So what is the relationship that is going to exist between Z and X given as such? So we had said that we can be able to find this relationship whereby we say that there's a vertical angle postulate for these particular parallel lines, whereby we're going to see that Z is going to be equivalent to X given as such, so long as this specific lines is going to cut across this one, then therefore there's going to be an equivalent of vertical angles which are going to be given as such. So from this specific case, then therefore if Z is equivalent to X, we can be able to conclude that Z basically or X basically is going to be equivalent to Y from this specific relationship that we're going to give. So therefore, if we have two corresponding angles like this, we're going to use that specific relationship of the vertical angles or the corresponding angle postulate in order to conclude that by the transitive property, then therefore this is going to show that the alternate angles or the vertical angles of Z is going to be equivalent to Y, then therefore Y is going to be equivalent to X respectively. So this relationship is going to assist us in trying to find some of the areas that we can be able to describe in geometry. And from the linear relationship, we say that the angular or the extension of a straight line, of course, suppose we have Z, X, and Y, then the relationship between this Y and Z is that we can be able to have Y plus Z equivalent to 180 degrees, which is a stretch of a straight line, which we are going to see being exploited later in this specific discussion. So suppose we have a numerical figure for various angles for Z, X, and Y, then therefore we can be able to find a corresponding angle using that specific argument. So that one entails the corresponding angle postulate, which of course assumes that the two, which of course we have illustrated that the two angles are going to be the same, and from the alternate angles, this is going to give us this specific conclusion that basically there's a relationship that is going to exist between the parallel lines and the alternate angles given as such. So that basically I think is elaborate to assist us understand the concept of corresponding angles insofar as the parallel lines are concerned, and this aspect of a transversal that I'm going to give us T. So catch us in our next videos. We're going to look at other areas of geometry, which of course are going to form a basis for us in trying to interpret the various aspects of its application. So that is it for now, guys. By God bless you. Catch us in our next video.